Okay, so today we are going to get to page 10. I'm logged into Zoom right now. Now, when we get into page 10, we're going to get into 2- and 3-step equations, solving them. And that's when we undo the operation, right? When we isolate x. And the tricky part is that we have to do order of operations backwards, which can be confusing. So before we start all that, I want to go over some of our vocabulary. Okay, so creating a zero term. Zero term is when the numbers cancel out to 0, like 4 minus 4 is 0. Okay, or -3 plus 3 is 0. And then one big factor is because it creates 1. So 1 times, or 5 divided by 5 is 1, right? Things like that. So when they cancel out to make 1, and then you times 1 times the variable, which is the variable. So 1 times x is x. Anyways, vocabulary here. An addition property of equality. What does that mean?
Adding to both sides of the equation.
Yes, adding to both sides of the equation. Okay. So you want to write that over here. I know we wrote it before, but let me make sure we're understanding that. So adding to both sides of the equation. And then what does subtraction property of equality mean? If addition property of equality means to add to both sides of the equation, what would subtraction property of equality mean?
Subtract both sides of the equation.
Yes. Let's see. Okay. Subtracting on both sides of the equation. And here is an example, right? When we minus 4. Subtracting on both sides of the equation. I forgot my period on this one.
Hi, good morning, Ms. Johnson.
Good morning.
Good morning.
Okay, so multiplication property of equality, MPOE, is going to be what? Which one is multiplication? Okay. Adding, I add to both sides of the equation. Subtraction property of equality, I subtract on both sides of the equation. Multiplication property of equality, what do I do?
Multiply both on both sides of the equation.
Okay. Multiply on both sides of the equation. And can someone explain to me, I don't know, maybe Ethan, can you explain to me why we're doing it to both sides of the equation and not one side? Why is that important to do it on both sides of the equal sign?
Because
Because
I mean I mean, because both of them are equal.
Yeah, we want to keep it equal. So if we do it on one side and not the other, the scale becomes unbalanced. So we want to make sure we do it to both sides so the equation remains true, remains equal. Very nice. Okay, so with the division property of equality, what do we do to both sides of the equation?
Divide.
Yeah. Divide on both sides of the equation. Cool. Okay, so show us that slide. So yeah, division property of equality, we call it DPOE, and it means we're dividing on both sides. Keeping it equal, then we're canceling it out. Oh look, there's a typo. It's supposed to have a 2 right there, isn't it? It is. That was supposed to have a 2. Okay. Whoops. That's the second error I found in my PowerPoint, and I made that a lot of times. Okay. So before we get into doing this stuff, I have video that we can watch for School Yourself. Okay. I also have the link for this posted. Let me refresh this. It says algebra multi-step equations.
Let's look at the equation x minus 5 equals 7. Suppose we want to solve for x. That means we want to do something to both sides of the equation, so it says x equals something. So what can you do to both sides of this equation to solve for x and get rid of this minus 5 on the left?
Okay. So it says minus 5. Am I going to add 5 to both sides? Subtract 5 from both sides? Add 7 to both sides? Or subtract 7 from both sides? Which one?
Add 5.
Yes. All right. Do you agree with that, Ethan? I have 2 people for add 5.
Okay, let's add 5 to both sides. On the left, we have x minus 5, then plus 5. Subtracting and adding 5 cancel out, leaving us with just x on the left. So nicely done. And on the right side, we have 7 plus 5, which is 12. So by adding 5 to both sides of this equation, you solved for x. It's 12. Next, let's look at a slightly more complicated equation. 3x plus 4 equals 10. So now the x is being multiplied by 3, and then we're adding 4. So how can we solve for the x here? Well, we can do this in 2 steps. First, let's try to get the 3x by itself on the left side of this equation. So what can we do to get rid of the 4?
All right. So he's saying,
4.
I'm sorry?
Subtract 4.
Oh, subtract 4. Yeah, because he said, I want to get 4 by itself. I'm not 4 by itself. I want to get 3x by itself. To do that, what do we do to 4? We remove it.
Okay, let's subtract 4 from both sides. On the left, we have 3x plus 4, then minus 4, so the 4's cancel out, leaving us with 3x. Perfect. And on the right, we have 10 minus 4, which equals 6. Okay, so now let's try to solve this simpler equation. What's the next step we should take so we have just an x by itself on the left side?
So it says 3 times x. Are we going to multiply both sides by 3, divide by 3, times by 6, or divide by 6? What option am I going to do?
Multiply.
Multiply by 3 or 6?
By 6.
Okay, sure. Let's try multiplying both sides by 6. On the left, we have 6 times 3x, which is the same as 18x, right? And on the right, we have 6 times 6, which equals 36. We wanted x by itself on the left, but now we have 18x. So give this another shot. How can we get x by itself on the left side of this equation?
Okay, I'm going to put a line through here. It said multiplying by 6 was not the best choice.
Multiply by 3.
Multiply by 3. Okay.
Okay, sure. Let's try multiplying both sides by 3. On the left, we have 3 times 3x, which is the same as 9x, right? And on the right, we have 6 times 3, which equals 18. We wanted x by itself on the left, but now we have 9x. So give this another shot. How can we get x by itself on the left side of this equation?
We divide by 3.
Okay, so what happened when we times? Did the number get bigger or smaller?
It gets bigger.
Yeah,
Bigger.
because I'm sorry, Jolene?
Bigger.
Yeah, because when we times, to multiply means we make it bigger. And when we divide, we make things smaller. Okay. So when we want to get rid of the 3, we want x by itself. We want this number to be smaller. So we're going to divide it.
All right, let's divide both sides by 3. On the left, we're taking x, multiplying by 3, and dividing by 3. So the 3's cancel out, leaving us with x. Nicely done. And on the right, we have 6 divided by 3, which equals 2. So the solution to our original equation is x equals 2. Let's double check that by plugging in 2 for x. That gives us 3 times 2 plus 4 on the left. 3 times 2 is 6, and 6 plus 4 is 10. So yes, 2 is the correct solution to this equation. How did we get that? We simplified step by step. First, we subtracted 4 from both sides to get rid of this 4 over here. Then we divided both sides by 3 to solve for x. Try using this step-by-step approach on another equation. 4y minus 9 equals 15. Can you solve for y?
Okay, what are we going to do? I have 4y minus 9. What do I want to do first?
Add 4 to both sides.
Add 4. So this says 4 times y. So do we want
Plus 9 on both sides.
plus 9 on both sides? Because we have to do order of operations backwards, right? So when we solve for x, let me write GemDAS here. Oh, that looks horrible. You know what? I think I could text it on there. I was just kidding. That looks awful. Okay. So we have GemDAS, but we need to do it backwards. So when we're doing it backwards, we're starting with addition or subtraction, which can be confusing. So Jolene said to add 9, which is correct to both sides. Because on this one, it said plus 4. So we had to do the inverse operation, the opposite. So we minused 4. But we start with addition and subtraction. So now that I did that, these 9's cancel out. And then I have 15 plus 9. So I'm going to rewrite the equation right next to it here. Notice how even though I'm doing work online, I am writing it on a separate piece of paper. Oops, that's not 15 plus 9 is, whoa, that was weird. Oh. 24. Yeah. I know our number line stops at 20, but if we had 15 and we went 1, 2, 3, 4, 5, and then 6, 7, 8, 9 would put us at 24. Okay. Okay, so now I have 4 times y equals 24. So what do I want to do next? We can look at this example that said 3 times 6, and it said divide both sides by 3. So if this says 4 times,
Divide both sides by 4.
all right, now divide by 4, okay. Do you agree with that, Ethan? Yes, cool. Oops, I gotta exit out of here so I can move the chat and then annotate again. Okay. So I'm going to divide, oops, by 4. Okay, so these 4s cancel out. And then 24 divided by 4 is
6.
6. Cool. Yes. Okay. So my answer, putting 6, that's what we got.
Exactly, so y equals 6. All right, now for a slightly tougher equation. Y divided by 4 plus 3 equals 8. Again, try using a step-by-step method to simplify this equation until you get a y by itself on the left.
Okay, and also if you guys are clicking on this link that I do have available for us, and I will include this link on the page 10 assignment, you can do this on your own. Right now, I'm in control of the screen, so I'm doing it, but you can absolutely have this interactive piece if you do it on your own, just so you know. Okay. All right, so y divided by 4 plus 3. I didn't mean to delete my term. Here's my PEMDAS, and I have to do it backwards. So I'm starting at the bottom and I'm going up. What do I want to do first? -3 on both sides. Yes. Right? And remember, the guy on the video said, just do it step by step. And that's exactly what we're doing. We're doing it one step at a time. Okay? So -3 on both sides. Cross that off. I'm going to rewrite our equation for us. Y divided by 4 equals 8 minus 3. 8 and minus 3, I go to the left. 1, 2, 3. I got 5. Equals 5. Okay, so now it says y divided by 4 equals 5. And I'm following order of operations backwards. So I can even cross this off if I want. I'm all done with this one. Next is multiplying or dividing. So what do I want to do?
Divide.
It says it's dividing, and I want to do the opposite.
I mean multiply.
Okay.
Multiply.
And when we write GEMDAS like this, it gives you the inverse operation, right? So if it's divide and you're thinking about this picture, it'll tell me I want to multiply. And I want to multiply by 4 or 5. What number? Because I want to get y all by itself.
By 4 on both sides.
Yes, 4 on both sides. Okay. I always multiply or divide the number that is with the letter, okay? Because that's how they cancel out. When I do that, it cancels out. And now y, when I rewrite it, is all by itself. Does that make sense? I'm not sure.
Yes.
It does? Okay. What is something that can help me to remember that when I'm multiplying or dividing, I always want to do it with the letter, the variable? Is there a trick, or is there something that, like Jolene, what helps you remember? Is it practice, practice, practice?
Yeah, practice.
Okay. Because if I can't remember and I'm like, oh no, I don't remember, which one do I want to do, right? I don't know. One thing I'm trying to say is you always want it to be smaller. So if you times 5, you wouldn't be able, it wouldn't work. You might get confused. So if you get confused, just rewrite the equation over and then start again and try the opposite. So I have 5 times 4 is 20.
20.
Jolene's fast typing today. Okay, put 20 up here.
Nicely done. There were a few different ways you could have solved this. One way is to first subtract 3 from both sides. On the left, the 3's cancel, leaving you with y over 4. And on the right, 8 minus 3 equals 5. Then you can multiply both sides by 4. On the left, you get y, and on the right, you have 5 times 4, or 20. Now, you could also have solved this another way. Instead of subtracting 3, let's first multiply both sides by 4. So on the right, we have 8 times 4. And on the left, you might be tempted to multiply by 4 like this. But this expression says you're just multiplying the first term by 4, and we wanted to multiply this whole expression by 4. We can do that by putting it in parentheses. Then we can distribute the 4 onto the sum. 4 times y over 4 gives you y, and 4 times 3 equals 12. And on the right, 8 times 4 equals 32. Then, to solve for y, you can subtract 12 from both sides. Once again, this gives you the same correct answer of 20. Okay, next.
So the way he just said, did that look like it was more steps?
Correct answer of
Yes.
Yeah. So that's why I don't do it that way, because then you have to distribute, you have to remember to times each item. So that's why I'm teaching you the other way.
But
This,
it still has the same answer though that we got.
yes, it gets the same answer. It does take a little more steps and it can be confusing. So if you want to do it that way, you can. I'm not saying it's wrong, okay? But sometimes when I show us a lot of different ways, it gets confusing. So if you want to do this, that is absolutely okay, because as you can see, you get the same answer. But you need to be comfortable with distribution and identifying all items that you need to distribute. But if you're watching this and you're like, whoa, what just happened? Don't worry, okay? You do not have to do it this way. That's your choice.
20. Okay, next, try an example where the variable is being multiplied by a negative number. Negative 2a plus 6 equals 20. Solve for a.
All right, he's telling you, I put a negative number in there. So what do I want to do first? I could put, oh yeah, oops. plus 2 on both sides. So if I plus 2 on both sides, we'll start it this way. Minus 6. Okay, so I see plus 2 and minus 6. Okay, so let me do the top one first because the top one said plus 2. So if I plus 2, well, actually, I can't really do it. I think Jolene's thinking to do it this way. But this says negative 2 times A, and that's tricky for us, right? Can we add when it's times? Is that the correct inverse operation?
No.
No. Whoop. Okay. So that minus number, in my head, I don't want to say minus 2 because then I'm going to add 2. I want to say negative 2. And if I need to put a dot in here to remind me I'm multiplying, I can do that. Okay. So in my head, I say negative 2 times 8 plus 6. So I'm going to minus 6 on both sides. So I want to make sure that when we see negative numbers, that we're really saying negative, not minus, because minus 6 does mean something a little different than negative, especially as we get into these more complex type of equations. Okay, so 6 cancels out. And I have 20 minus 6. Got my 20. My change is minus 6. So am I moving to the right or to the left?
To the left, it's
Ooh.
14.
Okay, nice. 1, 2, 3, 4, 5, 6, 14. Okay, let me see if I could just erase those numbers I just did so it's not on the screen. Here. Okay, rewriting the equation for us. Negative 2, put my dot here for times. A equals 14. Okay, what's the next step I want to do? I have negative 2 times A equals 14. And my goal is to get A all by itself. So what do I need to do? My clue is that it says times.
You have to divide.
Divide negative 2. Very nice. Okay. Okay, so I'm dividing by negative 2 on both sides. This cancels out. Woohoo! I got A all by itself. And then 14 divided by 2 is
12. 12.
14 divided by 2 is 12. 14 minus 2 is 12.
7.
Okay.
No.
Yeah, so I got 2, go to 14. I'm double checking on my times chart. Okay. So 7, and then a positive and negative make
Negative.
negative 7. Okay. Yeah. So I know that can get tricky, right? We're adding, subtracting, multiplying, and dividing. We have to think about all 4 operations. So it's really easy to look at it and think, oh, 14 minus 2 is 12. I knew that. You know, so I like to say the problem out loud every time. 14 divided by negative 2. So then I say divide. Okay, I need to use my, my times chart. So negative 7. Let's see if we did it.
Nicely done. So A equals negative 7. Next, let's look at an equation with a fraction. 2/9 x plus 7 equals 3. First, let's get rid of this 7 on the left by subtracting 7 from both sides. So on the left, we now have 2/9 x, and on the right, 3 minus 7 equals negative 4. Now, what can we do to get rid of this 2/9? Well, you may remember from multiplying fractions that it might be a good idea to multiply both sides by the reciprocal, 9/2. If we do that, then on the left,
Okay. So he's doing it by the reciprocal. which means he's doing 2 steps at once. What we do, notice how he also started with the denominator, right? So if that says divided by 9, we times it. So if that says 9 divided by 9 is 1 and it cancels out. And then over here, let me put something. Let me get a different color. I don't know, maybe I'll make black. Let me try and black this out for a second. Okay, step by step. So it divided it, or they canceled out, times it, and then -4 times 9 is -36. Okay, equals x times 2. And then what he did is, this one said times, so then he divided. Okay, so that's why that 2 is down here. We write ours different, so I just want to show you this way. Okay, because this is how we do it. It's the same thing, we just break it down into a little more steps. Okay? And then we get -6 divided by 2 would be -18. So again, we get the same answer. So if you're comfortable with flipping the fraction upside down and doing it that way, that's great. But if you want it step by step, I want to make sure I showed that really quick here. Okay.
The 9s cancel out and the 2s cancel out, leaving us with just x. On the right, we now have -4 times 9/2, which equals what?
Okay, so that's what we said. Now we have a whole number times a fraction. So that was the answer, -18. So this problem right here is why we do it in steps, because then you have to times a whole number by a fraction. And the way we do it, we get rid of the fraction first, so we don't have to worry about it.
Excellent. So x equals -18. Let's quickly double check that answer. If we plug in -18 for x, is this equation true? Well, 2/9 times -18 equals -4. And sure enough, -4 plus 7 equals 3. So this checks out, and -18 was the correct answer. All right, now try another equation with a fraction. Solve this equation for y.
Okay, so what are we going to do? I have a fraction times a variable, and then I have -5. Other things we can do, if this gets confusing, we can box our terms. Okay, if I box my terms, oops, that was bad. +5 on both sides. So after I boxed my terms, I saw that it reminded me that this is times. So I put it out there for times. Oh, it's still black. So I'm adding 5 to both sides. Now this cancels out. So the way we solve this is a 3-step equation, right? Because we're minusing, then we're timesing and dividing. So we did 3 things. So I rewrite it. I have 4/3, put in my dot, times y equals 7 plus 5 is
12.
12. Okay. Check the comments. 12. Cool. All right. Now what am I going to do? Because I have 4 divided by 3 times y equals 12. So what do I want to do next? I have multiply and divide, and they're both here. So do I want to start with the top number or the bottom number to get rid of my fraction? Bottom, good. I guess if that's over here, I can leave that there. So, starting with this bottom number, it says divide, so I'm timesing. These 3's cancel out. Now I have 4 times y equals 12 times 3. 12 times 3 is
36.
36. And now that it says times y, I want to do the opposite. What do I need to do?
Divide.
All right, now I'm dividing. Cool. Are we starting to feel a little more comfortable with this?
Yeah.
Yeah.
Sounds like it. I'm getting quicker responses. Now I have 36 divided by 4.
Nine.
Correct. So I take 4, I go to 36, and it is 9. Okay. So y equals 9. Okay. And then he's going to go back and check our work to make sure that 9 is a solution to the equation.
Excellent work. We can start by adding 5 to both sides. That leaves us with 4/3 y on the left, and on the right, 7 plus 5 equals 12. Then we can multiply both sides by the reciprocal of 4/3, which is 3/4. These two fractions multiply to 1, so on the left we have y by itself. And on the right, 12 times 3/4 is 9, so y equals 9. Next, take a look at this equation. 2y plus 18 equals 4.
Okay, we'll stop there. We're not doing variables on both sides of the equation yet. So now I'm going to bring us back to our assignment. Because when we do our assignment, there's some extra steps in here, or we also have to do different things. So I like it when we only need to focus on isolating the variable to practice for a while. Okay. So use the written property of equality figure. I said that wrong. Use the written property of equality to figure out how to solve the equation in that order. So they're telling us, they gave us the steps. They said SPOE, simplify. GPOE, simplify. Simplify means we always reduce it. I just have us, later on we'll write simplify at the bottom. Okay, so it says 5 times x plus 10 equals 20. And then when I'm looking at this, it says SPOE, so that's my clue. What am I doing first? It says 5x plus 10 equals 20. And then it also says SPOE. Minus 10, yes. Okay. So yeah, if I'm not sure what to do yet, there's a clue. So I'm gonna write minus 10, and minus 10. Let's see if that is that lined up. Why is this freezing on me? Oh no. Oh. Hold on, let me pause for. Okay, I had some technical difficulties. I think it was Claudia said minus 10. Oh, Angeline. Okay, minus 10 on both sides. Correct. Now these cancel out. Oops. Okay. So when I redo it, and it says simplify. So simplify means 20 minus 10. Writing what that is. 5x equals, and 20 minus 10, yeah, minus 10 is 10. Line that up. Okay.
Ooh, ooh.
Now I have 5x equals 10. So what do I need to do if this is times? And over here, remember, I have a clue.
Divide.
Yeah, DPOE. Now I divide. Oops. 5 on both sides. These 5s cancel out. Now x is all by itself. X equals 2, yes. 10 divided by 5 is 2. So I had to do 2 steps, right? I subtracted and then I divided. Now we go over here and it says is blank. So is 2 a solution to the equation 5x plus 10 equals 20. So what am I doing with this 2?
Rewrite it.
Yeah, I'm rewriting it. Okay, so 5 times 2 plus 10 equals 20. And we simplify. So am I doing the adding first or the timesing?
Times
Okay. 5 times 2 is?
10.
10.
Cool. So 10 plus 10 equals 20, right? I rewrite the entire problem. I line everything up. I want to keep it in order. Okay. And then what is 10 plus 10?
20.
20 equals 20.
20.
Yeah. And sometimes what we do is when we look at it and says 10 plus 10 is 20, we might stop because in our minds that makes sense. Like, yeah, 10 plus 10 is 20. We want to simplify all the way to the bottom. So does 20 equal 20?
Yes.
Cool. Okay. So put a check mark
Yes.
here.
Yes.
Yes. Right? We can write true. That means I did it correctly. Okay. True. So did you guys, we can try more. Do you want to do more tomorrow?
Yeah.
3 more.
Yeah.
Yeah.
Yeah, and those problems are more steps. Okay. Okay. So that's good for today. If you want to try that, you can, but I do have an IXL I'm going to post where we can get more practice. You don't have to worry about writing SPOE, DPOE, or anything, and you don't have to worry about checking your work when you're doing the IXL. It'll just be this part, okay? Seeing if you can isolate X. I'll type it in the chat right now, the shortcut for it. Let's say actually, the shortcut is QAK, like quack, and it is J.4. It's called 2-step linear equations, I believe. Okay, so I'll be posting the link for that, and that's an IXL where we can get some extra practice and get more comfortable with this. Does that sound good?
Yes.
Yes.
Cool. I'm gonna stop my recording.
Yes.
now.